2:30 in the morning. If you're watching this, that means I'm not at school, so it means we had a baby. This video actually has an alternate intro. I'm gonna save that till I get back, and we'll watch that. This was just the short version. Anyway, if you don't have pencil and paper out, you definitely want to get out some pencil and paper. We're going to take some notes here. This won't take too long, 10 minutes or so. And then I'm going to let you get to work on some of those problems that I gave you in that packet. Today we're going to start off looking at Chapter 8. This is really where we get into the real useful tools of linear regression. A little bit more about the linear model. We're going to talk about regression analysis. We're going to talk about, more specifically, residuals. Residuals can be a little tough to understand at first, a little confusing, but they're not bad. Once you get into it, you'll see what they're for, and they'll make a lot of sense. They might not to at first, but it's pretty easy. All right, here's the linear model. Now, we talked about basic association. That simply tells me if the relationship of the variables increase together, they're both increasing or both decreasing, that would be positive, or if they're inversely related, where one increases but the other decreases. Okay, we're going to take that a little step further. We're not going to just talk about in an association. We're going to take that correlation idea, and we're really going to take it a little bit further. We're going to talk about some of those formulas that we talked about. And in statistics, a lot of times, instead of using mx plus b, that's really reserved for more of an algebraic or geometric discussion. They use, a lot of the times, you'll see b0 and b1. b1, of course, would be slope. b0 is your y-intercept. This is in fact the exact way that your formula will show up on the AP exam. They won't use mx plus b. b0 is our y-intercept, of course. b1 is our slope. Make sure you know the differences. The next thing is those formulas that I said most people forget. Here they are. This is my y-intercept is equal to the average of the y's minus the slope times the average of the x's. Something that you'll want to note. This is probably not written out verbatim anywhere, but one point that will always exist on your least squares regression line is the point x bar comma y bar. If you were to plot the average of your x's and your y's as an actual point, and it's not an actual point in your data set, maybe it might be, but it's probably not. But if I wanted to find a point that I could plug in and work with inside the equation, then this is it, because I can always find the average of the x's and the average of the y's as long as I have the real data set. And that would be a way I can actually get my y-intercept. Okay, well, what if I needed to get the slope? If I have the standard deviation of y over x, and I have the r value, I can simply divide standard deviation of the y variable divided by the standard deviation of the x variable, and I get those things using one variable stats, or two variable stats maybe, or, and probably more appropriately, this is where I'm going to give you a list of statistics, and I'm going to ask you for the least squares regression line, and you're not going to be able to use linreg because you don't have the data set. You have to be able to get that line in another way, and this is the way that you find it. So you multiply that division by the correlation coefficient r, and that's where I find my slope. Write those down in your notes. Yes, I mean everyone. This is important. You will see this again, and most people will forget it or confuse it, or they can't remember exactly how it goes together. You will see that again, I promise. And this is just a typical scatter plot that we found, right? If we were to draw the line of best fit through here, we've got a couple of, if you were to guess at the correlation coefficient, if you were to guess My guess is probably in the higher moderate range. It's probably in the 60 to 70 range, or 0.6 to 0.7 range. It is positive. This would be considered to be an outlier, but non-influential because it's going along in the direction of x and y. However, since this is really an outlier in the y direction, because it doesn't fit with the correct y value here, it should be in this direction at this y, not down here at this y. You would expect a point like this to be way back here. So this is what we call our influential observation. Don't forget about those things that we used in last chapter. This would be my least squares regression line with all of my points involved. And you can see here that you would never have drawn a line in like that because of this point, it's pulling my line down. I could count the number of dots that fall on this side, 5 dots. And definitely more than 5 dots fall above it. So immediately you can tell that this point is pulling the line down a lot more than it needs to be. If I were to remove that line, that point, and regraph it, you would see that line turn upwards, probably closer to that value right there. Let's go back to that Burger King data. The line for that particular set of data, if you've actually read through the yellow book in chapter 8, it uses the Burger King example to begin that chapter with, and if you can actually write down the data. I think the data is actually in one of the questions from the last chapter that I gave out. This particular line was, now you'll notice something real interesting, that they instead of using x's and y's, they use the name of the variable. That is key. That's important. Is it absolutely necessary? No, but it definitely helps you to put things in perspective and to keep things in context. Things put in context is very important, super, super, super important. So make sure that you're doing that. Okay, we're going to talk about things being in context. It says in context, describe the slope and the y-intercept. And here's a hint. If you didn't use the words fat and protein, guess what? It's not good enough. You didn't do a good job. So if I were to talk about the slope, 0.97, you would say, as I increase one, let's say they're in grams. If I increase 1 gram of protein, I would expect the fat content to increase by 0.97 grams. If I look at the y-intercept, if I have 0 protein grams in my Burger King menu item, I would expect to have 6.8 grams of fat. Okay, so that y-intercept says if the x value is 0, if it has no value, then the y-intercept is what you would expect to see in whatever the y variable actually is. And you can see the chart that we had from the last video, the last PowerPoint. Assumptions and conditions. There's a few things here. This is where we kind of get into talking about our residual values. A residual, just simply what it is, definition in plain English, is really how far off were we. If I had created a least squares regression line and I was using it to try to predict test scores on the next test, and I'd predicted that a particular test score was going to be 95, but the actual test score turned out to be 90, then I would have overestimated that value by 5 points. So my residual would have been 5. A residual value is observed minus predicted. A positive residual means that I overestimated. A negative residual means I underestimated the value. When you're using and talking about residual values, you're really talking about the actual value minus the residual value. Okay, so there's the formula. it would be residual equals observed y values minus predicted y values. A residual, if you're visualizing a residual, it's the vertical distance a point is away from its vertical position on the least squares regression line. One of our conditions that was super important so far, and this is really the only one we've talked about, is called the straight enough condition. In other words, we had two conditions. It needed to be categorical or quantitative, and it needed to be straight, not quadratic, not curved, not anything like that. And so we have a couple other things we're going to talk about. We're going to talk about what we look at with residual values, and we're going to talk about how do you look at the residual values and make it play a part of this. So this one fails which assumption or which condition? That one is definitely not straight. So that means it's not linear. Now we are looking at residual values here. These are all residuals, not the actual scatter plots. A residual value, a graph, actually takes your scatter plot and exaggerates its non-linearity. And so this is bad, this is good. You want to see absolutely no pattern in the residual. If you see no pattern, that means it's linear. Here's another one that we're going to talk about. This has a funny name to it. It's actually called does the plot thicken? What's bad about this particular one is this is your actual scatter plot. This is your residual plot. What you see here is close to the beginning. It's really close to your line. But as you go along the x-axis, it comes further and further away. So in terms of accuracy, you're very accurate to begin with. But as soon as it gets beyond a certain point, you lose all kind of accuracy, and it's pretty much not really worth it anymore. So this would have a problem. So does the plot thicken here? Yes, it does. So it would fail that assumption or fail that condition. You always want to look at your residual plot to verify this is not happening. Now, if something like this were to happen, it's not an end-all be-all of the whole test, but you would want to make a note in your write-up saying this is a problem. We should be careful about it. It doesn't mean you stop and end of game. Just keep going. Make sure you take a note of it. The next thing we're going to talk about is called the coefficient of determination. This is the R-squared value. This is a little weird. What you're going to want to do for this is you're going to want to memorize the way it's described. By definition, it's the square of the it's the value that varies around the line. So the key word here is percent of variation. Right. So let's talk about study habits. Let's say hours spent studying and test scores. So if I had, let's say my R-squared value was 0.99. So that would say 99% of the variation of my test scores around my line of regression could be explained by the number of hours you were studying. There's 1% that caused the variation to be due to some other variable that I'm not taking into account. Maybe you got nervous. Maybe you're a bad test taker. Those factors aren't included here. Read up on coefficient of determination. That's definitely something that you can just read through. What you want to be able to identify is that kind of the way they describe the answers. And we talked about this in class. This is on the very front page of your homework, of the packet that I gave you. You just want to make sure that you know. Y'all hear that? He is not happy. At the end of the handout I gave you, you've got all these pieces. You're going to want to know each and every one of these, except for the part that's circled. You don't need to know that part. Okay, but here's the things you really want to make sure you know. The x variable, the standard deviation of the residuals, r squared. Now notice that it might not give you r, it doesn't give you r in this problem, but I have r squared. R is found by taking the square root of r squared. It really is connected that way. Okay, you wanted the y variable, the slope, the y-intercept. If you check out that sheet that I gave you, then you will find you'll find all those listed, and it's written out, very easy to follow. Okay, the r squared adjusted, that is not r squared. Just ignore that. I don't think we ever use that. And that's it. What I want you to do is take out the problems that I gave you yesterday, or day before yesterday. It was yesterday when I wrote this. I want you to complete no fewer than 10 problems. You have until next Wednesday to do this. But go ahead, and you'll probably be able to get most of that done in class today and probably in class tomorrow. We do have a lab scheduled for tomorrow, but we are going to postpone that. This lab will be, it's the Tootsie Pop lab. We will explore that. I'll have to let you know, maybe Monday. What I want you to do is I want you to bring in a Tootsie Pop of your own personal flavor. You can bring a bag and share, or you can buy an individual, whichever you care about. Bring those in. You can start bringing them in tomorrow, or you can bring them in. You can bring them in on Monday, but I will let you know this a little bit later. I am probably going to be at school on Monday at this point, but I'm not 100% sure on that. So if you go ahead and prepare for that, then we can maybe look ahead and try to get there. Otherwise, get to work. Please use your time wisely. Please share that yellow book. It's got some really good definitions and explanations about some things. Look over that, and hopefully we'll see you tomorrow. I won't be there, but I might still see you, so good luck. Don't give the sub a hard time.